Now we're going to look at multiplying polynomials, and I'm going to show you several different methods for doing that. But first, to multiply a monomial and a polynomial, multiply each term of the polynomial by the monomial. In other words, you're going to distribute. After multiplying, if possible, collect like terms. So here we have an example of a distributive problem. So I'm going to take what's on the outside and distribute it to the inside. And we might have to use our exponent rules when we're doing this. So negative 4x times 2x, that's going to be negative 8, and x times x is x squared. And negative 4x times negative 3, and negative times negative is a positive, and 4x times 3 would be 12x. So all we're doing is distributing. So let's do this last one. 10x squared, I'm sorry, 10x times 5x squared. Well, 10 times 5 is 50. X times x squared would be x cubed. Remember, when the bases are the same, add the exponents. 10x times negative 8x, well, that would be a negative 80x squared. And finally, 10x times 7 would be 70x. Now what happens if we have, we don't have just a single term on the outside? In other words, a binomial times a binomial, or trinomials. We can actually do a double distributive. So that's one method, and that would be where you need to take the x and distribute it, and then you have to take the 1 and distribute it. And you can see there's 4 distributions, so we would have 4 terms. So when we do it that method, if I take the x and distribute it first, x times x would be x squared. X times 8 would be 8x. When I distribute the 1 times x is 1x or x, and 1 times 8 is 8. And then I can combine my two middle terms because they are like terms. So x squared plus 9x plus 8. So that's one way to get the answer. Another way to get the answer, so I'm going to show you several different methods, is to use the box method. So in order to use the box method, I'm going to draw a box. I'm going to make it 2 by 2 because I have a binomial times a binomial. And I'm going to take my 2 binomials, and it doesn't matter which one you put on top or on the side. So I'm going to put my x and my plus 1 on the top, with my x and my plus 8 on the side. And now you just take and you fill in the boxes. So I've got x times x would go in this box, x squared. 1 times x would be x. X times 8 would be 8x, and 1 times 8 is 8. And this doesn't happen all the time, but most of the time your like terms fall on the diagonal. And so I have my original x squared. I can combine 8x plus x and get 9x. And then I have my lone 8. So that's the box method. And then I have another method that is unique only to binomials times binomials, and that is called the FOIL method. And this just helps you remember what to multiply. So it stands for first, outer, inner, and last. So when you look at your binomials, FOIL helps you keep track of your multiplications. So my first terms would be x times x, which is x squared. My outer terms would be x times 8, which is 8x. My inner terms 1 times x, which is 1x, and my last terms, which are 1 and 8, so that would be 8. And again, when I combine my two middle terms, I get x squared plus 9x plus 8. So you're going to have several of these in your assignment, and there's several in your workbook, and I encourage you to try several of them, and just pick the method that works best for you. Most students, when it's binomials, prefer to use FOIL, but again, that only works on binomials. Here in a minute, when we look at trinomials, we're not going to be able to use FOIL method. Other students prefer box, and some actually double distribute. Double distribute's not difficult unless you've got more terms, and then sometimes you lose track of what you've multiplied and what you haven't, so I encourage you just to draw arrows on that. But you can pick any form. So here's an example of a trinomial times a binomial. So in this problem we can't do FOIL, but we could do a box, or we could do distributive, or we could actually do like setting it up columns, and I'm going to show you those three methods. So if we were to distribute, we could take this x and distribute it 3 times, and then I'd have to take that minus 2 and distribute it 3 times as well. See how it can get kind of confusing if you just rely on distributive all the time? So I would probably use box method on this one. And since it's a 3 and a 2, my box would need to be a 3 by 2 as well. So I would put my x squared, my x, my positive 2, and then I'd have my x, my minus 2 over here down the side. And when I multiply, just fill in the boxes. X squared times x would go in this first box. That would be x cubed. X times x would be x squared. 2 times x would be 2x. X squared times negative 2, that's negative 2x squared. X times negative 2, negative 2x. And 2 times negative 2 would be negative 4. Now combine my like terms. You can see they fall on the diagonal. And I have, it looks like x cubed. I have minus 2x squared plus 1x squared, so it would be minus x squared. Negative 2x plus 2x, those zero out. But I still have a minus 4. So that's one way. Another way that you could solve this problem is actually to treat it like a 2-digit times a 3-digit. And what I mean by that is just stack it. So if we have x squared plus x plus 2 times x minus 2. So this is similar to if you had, let's say, 324 times 28. So this is the process that we would use for that. Remember, when you would solve a problem like this, you would take that 8, and you didn't know it at the time, but you were actually distributing it to everything in the 324. And then you'd go back and do the same thing with the 2. We're going to do the same thing. So I'm going to take my negative 2 in the lower right, and I'm going to distribute it to everything in the polynomial above it. So negative 2 times 2 would be negative 4. Negative 2 times x would be negative 2x. Negative 2 times x squared would be negative 2x squared. Then you would go through and do the same. The x. X times 2 is 2x. Now notice I lined it up with its like term. And it's positive 2x, so I put a plus. X times x is x squared. And x times x squared is x cubed. I'm running out of room. And then you would draw a line, and then you would add straight down. In other words, collect your like terms. Negative 4. Those zero out. I get negative 2x squared plus x squared would be negative x squared. And then I have my x cubed. So same answer that I got with box method. But here I just set it up differently and treated it like a 3-digit times a 2-digit. Cannot use FOIL because it's not a binomial times a binomial, but you could do distributive if you wanted to.